Today we'll be solving May June 2024 paper 22 15-mark question, and this is one of the more technical and difficult ones, especially because this question was asked in a bit of a different format than the ones preceding it. So let's go through the question and we'll plan it, visualize it, and then we'll solve it. Alright, so the question says there is a one-player game that uses a 2D array called grid to store the location of a secret cell to be found by the player in 10 moves. Okay, so this is sort of a game that we have to make like battleships. If any one of you has played on Minesweeper, we will have a grid and we'll do the movement of our object on that. Then each row has 5 cells and column has 5 cells. So we have a grid of 5 by 5 in total. So we'll be looking at a 5x5 grid, which means there would be a total of 25 cells. Alright, at the start of each game, the player will place an X in a random cell not in grid 1,1. Okay, so they're saying that you are not allowed to put any X in here. Okay, for the sake of convenience, we'll visualize it using a battleship. So you are not allowed to put a battleship in this part. Okay, so we cannot do that. All right, then it says, and it empties all the other cells in the grid. So initially we will keep on generating a random coordinate for X and Y until it is not equal to the starting point of the grid. The player has to stop after 10 moves and the player starts at the top left of the grid. Okay, so the starting point is going to be 1 by 1. So let's write this down as well. We'll start from 1, 1. All right, this would be the starting point. And then we'll have 10 moves. If within the 10 moves we can find the right position of the X or our battleship, then we win the game, otherwise we will lose. So now there are some rules that we have to follow. Alright, during the game the player can move left, right, up or down by one cell only. Okay, so you cannot have multiple movements in one turn. U1 is displayed if the player moves to the cell with X and has played 10 moves or less. Alright, so you allow 10 moves and you will show a win message if it is done within 10 moves or less. And you lose is displayed when the player has made 10 moves without finding the X. Alright, so this is a very simple guessing game. Basically, you have a puzzle on a board on a grid and you have to just find the location of that puzzle on the grid. So you must use pseudocode or program code, add comments, and you do not need to declare any arrays or variables, and you must have suitable messages for all the inputs and outputs. Alright, so how do we go about solving this? The question looks very easy when you read it, but it's a bit more technical than that. First of all, let's look at the script that we have in front of us. Here we'll start from the first part, and then every time we'll move left, right, up or down, and for the sake of convenience I have shown this X here highlighted. Obviously this would not be the case in the game. Alright, so let's say if I press right, this ship should technically move to this point like this. Alright, then let's say if I press down key, it should go here. Then if I press right key, it should go here, then right, and now next time if I try to print right again, this will go out of the grid, and this is not allowed. This is an invalid move. So every time we move, we first need to make sure that our ship is within the bounds of the grid, and our grid is 5 by 5. So every time we have to check if the ship is between 1 to 5 row and if it is between 1 to 5 column. If that is not the case, you will not end up moving the ship. Instead you can show some error message, and if it is not the case, then you will allow the ship to move like this. All right, so let's say we did not go towards right, press down arrow, I press down arrow again, and then I press left, and that's it, we win now. But how many moves did we take? 1 2 3 4 5 6 7 8 9. Okay, so we technically win. But let's say I have how many? 1 2 3 4 5 6 7 8 9 10, and since I still did not land on the X, I will lose this game. Okay, so the only catch here is that after every move you need to check if it is within the bounds of the grid or not. That's the only thing that you have to do. So this is the rubric that we'll be looking at, and again I'll undo this. This would be our starting point. Okay, so first of all, we should also identify what sort of library routines we'll be looking at. So it should be very obvious to you that since we have to generate a random position that is not 1 by 1, so we have to use the random function that is given to us in the syllabus, and it's mentioned in the pseudocode guide as well. And other than that, I don't think there is any library routine that is needed here. So in summary, what we have is we'll have 10 moves, and at each move we have to check if the moves are less than 10, and if we have not found the X yet, okay, or the goal yet where we want our battleship to go, then every time we will input some move and we'll check if the move is valid or not. If it is valid, then update the coordinates on grid. Otherwise, you will show an error. And we keep on doing this until we either run out of lives, 10 lives, or we end up finding the X mark on our grid. Okay, so this is pretty much the whole idea. All right, so let's start and work towards it. Okay, so first of all, the question says that we need to have an empty grid with X placed not in the grid starting left, top left side. So how do we do this? Okay, so we say generate empty grid. Okay, in order to generate this, we need a nested for loop. Again, the reason is that we have rows and columns here, so we cannot iterate the whole 2D array without nested loop. So for row 1 to 5, for column 1 to 5, then we say grid. At this certain row and column, you need to put an empty string, and then you say next column and then next row. Okay, so this will generate an empty grid. So if I were to clear this, so this is how the grid would look like initially. Okay, it would be totally empty. Now in the next step, we are asked that we have to generate the x coordinate and y coordinate of our goal, the x mark. So let's do that, and we cannot stop until we make sure that it is not set at the top left corner. Okay, so now we generate the coordinates for x mark. All right, so this mark that I'm talking about. Okay, so for this part, you can use the repeat until or you can use the while loop. So repeat until is simpler choice in this case. So we will repeat until our x coordinate is not equal to 0 and our y coordinate is also not equal to 1. So what do we do inside? We have to generate a random value each time. Okay, now we'll look at the random function first. So if you quickly look at the pseudocode guide from the syllabus, here you see the random function. So random returns a random value between 0 and 1 inclusive. Okay, so you cannot put a range in this random, although it is allowed in A level but not in O level. So now you need to generate a random number between 1 to 5, and you can clearly see it says it generates from 0 to 1 by default, and you cannot add any range inside random function. So if I only write random times 4, now what this will do, this will generate random number from 0 to 4. Okay, because if this generates a 0, then 0 times 4 is 0, and if this generates a 1, then this is 1 times 4 is 4, but we want it to be between 1 to 5. So maybe let's do it with 5. Okay, so now we need to have 1 here as well, 1 to 5. Now the general method of generating a random number in a certain range is that we write value or rand value is equal to the minimum value plus random function times the difference. Okay, now what is happening here? The difference would be 4 in our case, 5 minus 1 would be 4, and then the minimum value would be 1. So this would mean 1 plus random times 4. So if the value is, if the random generates 1, that means you get a 4 here, and then 4 plus 1 would become 5. If the random generates 0, then this all becomes 0 and you get the minimum value as 1. Or if the random generates any value in between 0 to 1, like 0 0.5, 0 0.9, then we can round it off and we can still use it properly. Okay, so this is the general function that we have to use. So here we'll say 1 is the minimum value times difference in our case is 4, and we'll put this inside brackets. So this will give us a random x coordinate, and then I can repeat the same thing for the y coordinate, and that's it. But this will generate real value. Okay, again, as the pseudocode guide says, it will return you a random number which is in real form, so you need to use the round function to convert it into a whole number. So in order to get the goal here, so let's call it x goal. So I'll have to round this x value to nearest whole number 0, and then y goal would be also to round y to 0. And with this, we will generate x and y coordinate for the goal. All right, and this will make sure that they are not both 1 and 1. Top left corner is not allowed. So we're done with this part. Then in the next part of the question, we are asked that now you have 10 moves and your player can either move left, right, up, or down. So we need to now start adding these functionalities. So first, let's set some values here. So maybe initializing values or variables. First of all, we have the grid, and we have to set the goal here. So the goal would be on x goal and y goal, and at these coordinates we are going to put our x. Let's assume that these were the coordinates for x and for y. All right, then now we need to start from the top left corner. So maybe let's call these player row as 1 and player column as 1 as well. Again, you can name them anything you want, it's totally up to you. Then we have moves, that would be, sorry, moves not movies, would be set to 0, and initially we are assuming that we have not found the x, so it will be set to false. And we should also output on the screen to tell the user what they have to do. So find the hidden x in the grid, 10 moves allowed, something like this. So till this point we have initialized all the values that we require. Now our grid should be exactly in this format as you see here. And now we'll start moving the battleship to eventually reach the goal. Okay, so let's say implementing game mechanics. All right. So as I discussed before, that we can only end the game at two conditions. Either you run out of lives or you end up finding the X before you run out of 10 in life. So this would be our terminating condition while moves are less than 10 and found is equal to false. So this means that as long as your moves are less than 10, again, you have not used all the lives, and secondly, found is false, that means you still haven't found the goal mark. So until and unless both conditions are true, you will keep on repeating the whole thing until this condition is satisfied. Now let's start. So they're saying that you need to tell the user that they can either move in four directions, and it would be nice if we can give the x and y coordinate at every point. So let's say if the user moves down here, so we can tell them that the current position is 2x and 1y. Then if they move right, then we can tell now the x is 2 and y is also 2, something like this. And we can also output the number of moves left at every turn. Again, it's totally up to you. So output, you are at position row, comma player row, comma column, comma player column. And again, you can output any sort of message that you want. Output, enter your move, which could be left, right, up, or down. And now we'll ask the user to input the move. Okay, so this might get confusing, moves and move. So maybe we can call this life, and we should, or lives, and we should also change this to lives. So we input the move. And just to make sure that if the user inputs a lowercase value, it should be uppercase. So we'll convert this move to uppercase using the U case, which is part of our syllabus and the pseudocode guide. And then the new coordinate that we'll have once the player will start to move, we'll keep on substituting them. So new row or updated row would be the player row for now, and the new column would be player column. So far, the player column and player row are technically 1 and 1. So the new row would also be set to 1, and this would also be set to 1. From this point onwards, now we're going to move. The reason we have to use these two variables is because when you move your battleship like this, so your coordinates would update. So the previous one should update new value. So these would be the previous coordinates then, and these would be the new coordinates then. And we'll only update them if they are valid, if they are within the bounds of the grid. All right, let's start with the moves. Now we have left, right, up, or down. So if the move is equal to left, what do? We will move the column. So let's say if our ship was here, maybe at this point, so you want to move left. So what are you technically doing? You are reducing the column by 1 and the row remains the same, right? So we go from 2 to 1. So this is what we're going to do. We'll say new column is equal to the current value of the column minus 1. Again, we need to use two variables because one is the previous value and the current one is the new value. Then else if the move is equal to right. Okay, so let's assume instead of going left, we move to right now. So this column from 2 will go to column 3. So we are changing the column by 1. So we'll add the value 1 like this. Then we do the same thing for the left part. So else if move is equal to left, then what happens? Maybe up. Okay, so now from this point, if I go up like this, so now we are changing the row. From row 2, I went to row 1. So row would be subtracted. So new row should be player row minus 1. Else if move is equal to down, and you add again y, because if I move down, now I am changing the row by 1. From 2, I went to 3. And then otherwise, if none of these moves were entered, so I can just simply output invalid move, enter left, right, up, or down, and we end. Till this point, we have only changed the coordinates if the moves are entered correctly, left, right, up, or down. Okay, now we are going to validate them. If they would be valid moves, then we will update the coordinates. So validating moves and updating coordinates. So what should we do? Again, if we are at this point, maybe if the battleship is at this point, first row, third column, and if I try to move up, so this will go out of the grid and this should not be allowed. Similarly, if I go left, that is a valid move, so it should update the coordinate. This is what we have to do. So in order to do this now, we will be using if condition and we will update the values as it is. So if new row is greater than equal to 1 and new row is less than equal to 5. Okay, again, since we updated these coordinates from player column to new column and new row, now we have to check Okay, so let's say the player decided to go up, and if they go out of the grid here, now we will be penalizing them. Now we'll be, not allowing this move. But if they made a correct move, like going down from here, so this should be allowed, and this should update the coordinate. So if the rows are between 1 and 5 and new column is greater than equal to 1 and new column is less than equal to 5, like this. So if all of them are within the grids, within the bounds of the grids, then this moves would be allowed. Okay, so now we are going to update them. We will say now the player row, the new position would be player column, new column. Okay, so what happened now? Since this was the current position that we had saved in the new call, and now since this move is allowed, since this move is perfectly within the rules of the game, we will update the coordinates and will say that the new row, whatever the value we saved in this point in time of the program, we will update them to the current player row and the current player column. So now this would be the current coordinate of the ship, the one in the player one column. Similarly, if the ship decides to go right at this point, since again this is a fair move and correct move, so this would become row 2 and column 4 would be the new coordinates here in player row and player column. So again, we allowed the user to move. So it depends on the game that you're playing. In some games you cannot even make an invalid move, right? You will clearly be instructed not to do so, like how when you try to go out of the arena in some games and it starts showing you warning and your health starts decrease. Okay, but in our case we are allowing an invalid move, but we will validate that afterwards, and then we will print a message if it is allowed or not allowed, but we will not update the coordinates until and unless it is the correct move. All right, now we need to check if it is equal to X or not. So we allowed 10 moves, and within 10 moves the user has to go to the goal, like this. So we check if the grid at player row and the player column is equal to the X mark, we will set found equal to true. Why? Because we set found initially to false, and this is a very important part of our while loop. We are saying that until and unless found does not become true, we will keep on repeating, or while the found is false. So we say found becomes equal to true. So let's map this quickly. Let's start from here. So one move, 2, 3, 4, 5, 6, and 7. So this should be one course of action that you can take. So we will output you win, you found X in this many moves. All right, or if you don't want to use the word moves, so you can use you win, you found X in lives, comma lives. So let's say if the value of lives was 3, so this should output you win, you found X in 3 lives. All right, and then we end it here, and we also increment the moves by 1 because this was a move that was allowed. So this was move 1, then 2, 3, 4, 5, 6, like this. So we do move by 1. If we don't do this, then our loop will go into an infinite one because we will not be changing. Sorry, this should be lives. Okay, so if we don't change this, this will go into an infinite loop because lives will never become more than 10. So this will keep on going. So this is very important. You can say incrementing lives by 1 after each turn. Okay, if that is not the case, let's say if the users made an invalid move, something like at this point they decide to go up, which is not allowed, so we should output some error sort of a message. So we'll say else output you cannot move outside the grid, something like this, and maybe try again. It's totally up to you what you want to do. And then at this point we will end while. Okay, so far what we have done is we generated a grid that is empty, then we generated random coordinates for the goal for the X mark, then we put the X mark there, we run a while loop, we ask the user to make their moves left, right, up or down, we change the coordinates in the code but not on the grid, we check if all the moves that the user makes are valid. If that is the case, then we update the coordinates, and then we check if it is equal to the X mark on the grid, then we set found to true, and then we output whatever user lives were there at that point, and we increment the lives by 1 if the move is not correct. And otherwise, if the user makes an invalid move, then we are going to tell the user that you cannot make this move because it's outside the grid. Also, you can just simply use an else here as well, that let's say if the move on the grid did not contain X, then only then you will increment the lives by 1, just to make it more sound. Okay, so now when the loop ends, there would be two conditions when the loop ends: either lives became more than 10 or found became equal to true. So we now need to check when the user loses. Okay, and in the question they've clearly told you that user will lose if they have not found the X within 10 moves. So either you can check that if lives became more than 10, or you can simply check if found still remained false. Okay, since we set found to false initially, and if throughout the loop the found remained false, which means this if condition never became true, which simply means that the user never reached the value of X. So we can simply outside the loop check if found was still false even after making the 10 moves or more, then you will output you lose X not found in 10 moves. Or you can also, just would be a better idea if you just tell the user that where it was. So you can say X was at, and you can add row, comma, what did we call it? X row? X goal. Okay. So was at row X goal, column Y goal. Just a small step that you can do. It's totally up to you. And then we end if, and this will be the whole program. And at this point, it will be the end of the program. And this will work 100% correctly as per the rubric given in the question for this game. Thank you.